Hey guys, this is Joe East again. This is another lecture in the battery system series. Today we're going to talk about accumulation of charge. So you might want to have either a computer science background or a mathematical background to understand this, maybe a little bit of differential equations. So those of you who are not hardcore math nerds, this might be a bit too much for you, but if you're into the mathematics, this is good stuff. Okay. Broad subject, battery systems. Specific subject, accumulation of charge. Okay, so if you're going to develop a battery system and you're going to measure how much state of charge it has at a certain time or the capacity at a certain time, and it's specifically perhaps a lithium system or a very critical system, you're going to want to account for accumulation of charge as you are using the battery. It's just a fact that you have to do. We're going to get a little bit technical here. So we have, in this particular example, a battery system, generic battery system. We are injecting a current into the battery system, any current, generic current, and we have an ammeter in the battery system. So that's very, the simplest example I can get is just stripped down system with a current injection machine and an ammeter in the circuit. Again, that's very simple. We can actually do the equations with this diagram. So let's go back to our electrical engineering equation for current, if you guys remember that in either high school physics or perhaps engineering school. So the current equation is that current is equal to dq over dt. Should I say the change in charge with respect to time, instantaneous. All right. So let me walk through that just slightly slower if we don't remember those equations. So again, current is defined as equal to the instantaneous change in charge divided by the instantaneous change in time. Okay. So what we're going to do is, if you remember from your differential equations or your calculus class, we're going to do separation of variables so we can get to a useful equation where you can plug it into a computer science or an algorithm, right? So that's where we're headed here. So we're separation of values, so we move dt up against I, and then dq is left alone, right? So again, I dt equals dq. All we did was perform separation of variables where we moved dt to the side of I here. I dt equals dq, all right? Current multiplied times the time interval, instantaneous, equals to the change in charge. Charge is always in coulombs, all right? Separation of variables. Now we're going to discretize the variables. Again, going back to either our college calculus or something like that. How do you discretize variables? Or perhaps computer science, you might have learned this. So convert dt into delta t. That becomes a time interval. I delta t equals to, let's discretize this instantaneous piece here, qn minus 1, all right? So the change in charge instantaneous, we can discretize it as the charge at time n minus the charge at time n minus 1. For example, the charge at time 10 seconds minus the charge at time 0 seconds. Very, very simple in concept. Just if this is kind of hard to catch immediately, just rewind this. I'll go through it one more time here. Again, current multiplied times the time interval is equal to the charge at time n minus the charge at time n minus 1. Let's rearrange the equation and complete it. That way you can immediately plug it into a spreadsheet or a computer algorithm, very simply. The charge at time n equals to the charge at time n minus 1 plus the current multiplied times the time interval, delta t. Okay? We just rearrange this equation here and get this. Okay, so you can plug this into a spreadsheet or a computer science algorithm for control systems, battery management systems, BMS, or whatever you want. This works, and that's the actual physics equations converted to a discretization formula. Let's do a dirty example here. For example, let's say I'm blasting 100 amps into this battery within a particular time interval. I'm going to see how much charge I accumulated, okay? So at time 0, I start hitting it with 100 amps, okay? Before time 0, I didn't hit it with any amperage, okay? All right? So at time 0, let's hit it with 100 amps, and let's hold that 100 amps until we get to 10 seconds later. Then we're going to immediately turn off the current machine and go to 0 after 10 seconds, all right? Let's plug this stuff into the current accumulation equation, and that way you guys can start using this in a spreadsheet or an algorithm. So the charge at time 10 equals to the charge at time 0 plus the current multiplied times the times interval, okay? Now the charge at time 0, given initial conditions, we're just going to say it's 0, okay? If this is a system that's been tested and you know what the charge actually is at time 0 and it's not 0, then you just plug that number into the time 0. But for this example, we're going to say Q0 equals 0, right? So 0 plus 100 amps times 10, all right? That's the time interval, right? Delta T. Very simple, straightforward, and that equals 1,000 coulombs. So in this particular example, we blasted 1,000 coulombs in the battery with this particular procedure right here, okay? Again, battery systems, accumulation of charge. We take the equations, we separation variables, convert them into discretize variables, and that way you could start using it immediately, practically. Again, this is Joe East. If you guys got any questions, feel free to contact with me. And you guys stay safe out there. Thank you. Take care.